Alright guys, today we're going to be talking about 6.1 and we are relating lines to planes. Does anybody even remember what a plane is? Anybody remember what a plane is? One of the areas, well, a plane does have an area, but if you recall from the past, guys, a plane is a surface such that if 2 points on the surface are connected by a line, all points of the line are also on the surface. Think of a plane, think of it as like the tabletop. Okay? You guys were eating Thanksgiving dinner. You ate on a table, I presume. That table, the flat surface, that was a plane. Well, guess what? The ceiling above you is also a plane. The floor below you that you stand and walk on is also a plane. The walls of your house are a plane. Okay? A plane is a surface such that if any 2 points on the surface are connected by a line, all points of the line are also on the surface. Yes, sir. That's where I'm going to right now. The question was it 2 or 3 dimensional? Well, if we're talking about lines, then a plane has only 2 dimensions, length and width. Okay? If you look over here, just right quick, just to show you guys, because this is not that difficult. If I have point A and point B, we know that any 2 points can be connected to create a line, correct? So, these 2 guys here are on the same line, they're collinear, and they're on the same plane. Okay, it's on a flat surface. That's a plane, and a plane is 2-dimensional. It has length and it has a width. Now, planes are infinite in theory. This rectangle here that we have, this guy right here, it's infinite. It goes on forever in both of the dimensions, length and width. But a plane, think of it as a flat surface, like a ceiling, like a floor, like a wall, like a table. Okay, a piece of paper, that's a plane. Does that make sense so far? All right. Okay, now, planes can be named by placing a single lowercase letter in one of the corners. You're going to see, for example, here, plane M. It's called plane M because of that little lowercase m right there at the corner. That is plane M. Now, on this plane, we have some coplanar stuff, and we have some things that are non-coplanar. If you remember, gentlemen, it's coplanar if points, lines, segments, and so forth lie on the same plane. So, some examples of coplanar stuff here. CD is coplanar because C and D are on the same plane. So is CF. So is FD. Those are all coplanar. Okay? Now, non-coplanar. Non-coplanar is if points, lines, segments, and so forth do not lie on the same plane. Now, look at this line here, gentlemen. Line EF. If you look at line EF, okay, it's kind of hard to really determine from this picture, but think of it this way. EF is a vertical line going through the horizontal plane M. Think of putting a piece of paper in front of you flat, horizontal, and wedging a pencil right through the center of it, vertically. Okay? They're on two different planes. EF and CD are non-coplanar. So an example of non-coplanar here would be EF and CD. Those are non-coplanar because they are on different planes. CD is on the flat horizontal plane M, and EF is on the vertical plane EF. They are non-coplanar. Yes, sir. Correct. What was asked was, again, if M was a horizontal, M is horizontal, okay, and EF is vertical. Those are not on the same plane. In fact, EF is going above plane M. Does that make sense, gentlemen? Does that make sense, gentlemen? Okay, I got a head nodding. No. Take a piece of paper out. Put it up flat. On your hand, on the palm of your hand. Okay. Now, through the holes on the side, stick a pencil up through it. You see what I'm saying now, my brother? Thank you. For anyone watching this at home, do what I just said. Take a flat piece of paper, get one of the holes that are on the side, put a pencil or a pen through it vertically. Those are two different planes. Yes, sir. Correct. Do you see this dashed part here? That dashed part is representing that it's going through the plane. So therefore they are non-coplanar. They're not on the same plane. Yes, sir. Correct. If this was not dashed, that means it would be on the same plane. Correct, sir. Yes, sir. CD is on the flat horizontal plane M. Okay? Since CD is on the flat horizontal plane M and EF is vertical, they're not on the same plane. Does that make sense? Are you sure? If not, take out a piece of paper, hold it flat, horizontal. Now stick your pencil or pen through one of the holes vertically. Are they in the same plane there? Does that make sense to you? Does that make sense to everybody? Correct, sir. Yes, sir. Would point E be non-collinear? Point E will be non-coplanar to any point on plane M. Yes.
Why there was no dashed line for EF be coplanar? E's outside.
Okay. The question was, if this part down, if this was solid, would those be coplanar? The answer is yes. The answer is yes because you have two lines now intersecting, which defines a plane. We're going to get more into this, guys. And we're making a mountain here out of a molehill, though. What don't we understand about the fact that you have a flat surface, a horizontal surface? If you put a line vertically through that surface, are the line and the plane on the same plane? No. Think about this, guys. When you were eating dinner this weekend, you ate on the table. You do have, the table does stand on 4 legs, correct? Those legs are vertical, correct? Are those legs on the same plane as the actual table that you're eating on? Yes or no? No. Yes, sir. It wouldn't be going through the paper if that was a solid line. That's the whole point, guys. It's dashed because it's showing that it's going through. But since I don't have the capabilities of drawing a 3D figure, this is the best that I could do, gentlemen. Okay? Yes, sir.
There was a D on top of the E.
Yes.
Line was solid. D and B on the same plane.
If there was a D on top of the E, what was your question now?
And the line was solid. Would it be on the same plane? Would D, E be on the same plane?
And the line was solid, would that be on the same plane? For the 15th time today, yes. Okay, guys. It is outside of the box because I am trying to illustrate the fact that EF is going through the plane. It's not on the plane, but it's going through the plane. Almost like the example of take out a flat sheet of paper, put a pencil or a pen through that paper. Is that, are those on the same plane in that particular case? Okay, no. Now we're going to move on, guys, regardless of if you got it or not, because at this point I think that we're just being redundant. Now, let's look here to understand whether or not you got this. Let's be clear with this drawing. RP is going through plane M. It's going through plane M. Okay? So what I'm trying to draw here is a flat sheet of paper, which we're going to call plane M, which is horizontal. And we put a pen or a pencil or a straight object vertically through plane M. That's why we have dashed lines. Okay? Now I'm going to go ahead and take some answers out of this box, and you're going to tell me where it goes. Does it go to coplanar or to non-coplanar? So for example, A, B, S, T, and RP. A, B, S, T, and RP, are they coplanar or non-coplanar? They are non-coplanar. Why? Because RP is going through the plane. It's not on the same plane. How about line A, B, S, T, and RP? Non-coplanar as well. Segments and lines behave the same way for planes. How about A, B, S, T, and R? Non-coplanar. R is above plane M. It's going through plane M. It's not on the same flat surface. How about AB and ST? AB and ST are lines on the same plane. Absolutely, they are coplanar. And how about line AB and line ST? Also coplanar. Does that help make sense, gentlemen? The question was, if it's outside the box, is it non-coplanar? No, that is not what I'm saying, guys. Remember that I told you that planes are infinite. So if I have a point here, and a point here, and a point here, and I call this A, B, and C, and I connect the dots to make a line. All of those are coplanar, because it is like taking a flat piece of paper and drawing a line on it and continuing on an infinite table. Exactly. Now, if I put a point here, D, but I say at this point D is going through the plane, DB is no longer coplanar to that yellow plane. Does that make sense, sir?
Was that why we labeled A, B, S, T, and R non-coplanar?
A, B, S, T, and R were non-coplanar because R belonged to a vertical line that went through the plane, not on the plane. Yes, sir.
Okay, when you said like AC,
AC is coplanar. Absolutely, because you are drawing on the plane, and a plane is infinite. It's a flat surface. So as long as you're drawing on the plane, it's coplanar. DB are not on the same plane as AC though. So DB and AC would be non-coplanar because they are not on the same plane. Yes, sir. It depends. You cannot just say D is non-coplanar. D is part of its own plane. Okay, that made no sense to me. You said to me, D is non-coplanar. No. D is part of the line DB, correct? DB has its own separate plane. AC has its own separate plane. Now, DB and AC are non-coplanar. But a point, just saying a random point is non-coplanar is not accurate at all. Yes, sir. R is not coplanar to the rest of the points because R is not on the same plane as A, B, S, and T. Okay? So if you're going to say that a point is not coplanar, you have to reference it to something. You have to relate it. You can't just say A is not coplanar. Yeah, it's not coplanar. Why? What are you talking about? It's not coplanar in reference to what? A and B are coplanar. A, B, and C are coplanar. Now, A and D, they're not coplanar. Does that make sense, son? Thank you for your honesty. Yes, sir. Yes, sir. There would be a third separate plane. The question was, couldn't you connect A, D, and C to create another plane or on the same plane? That would be a third plane being created then that you would have to create.
like that.
Exactly. It would be kind of like a 3D, yes. Okay? Now, let us continue. There are 4 ways to determine a plane. And the first one states that 3 non-collinear points determine a plane. 3 non-collinear points determine a plane. So the question that was just asked, can't A, D, and C create a plane? Yes, they can. But it wouldn't be either of the ones that you saw on the board. It would be a new plane that was created. So any 3 non-collinear points determine a plane. All right? A line and a point not on the line determine a plane. So basically a line and a non-collinear point determine a plane.
So,
Yes, sir.
they're still on the plane, but they're just not collinear.
The question was, they're still on the plane, but they're not collinear? That's exactly right. If we think about the postulate that we just saw, didn't it say that 3 non-collinear points determine a plane? Can't I get 2 random points from the line? and call it, let's say, A, B, and C. Aren't A, B, and C non-collinear? So therefore, I can determine a plane. So if you have 3 points that are non-collinear, just straight up points, non-collinear points, they will determine a plane. If I have a line and a point that is not on that line, they will determine a plane. If I have 2 intersecting lines, they will determine a plane. Again, here you can get 3 random points that are non-collinear and prove it using the postulate that non-collinear points, 3 non-collinear points, determine a plane. So far we have 3 non-collinear points determine a plane, a line and a point not on that line determine a plane, and not last but not least, our third one, 2 intersecting lines determine a plane, and last but not least, 2 parallel lines determine a plane. Yes, sir. When don't lines determine a plane? That's what we went through in the first part of the section. Correct, it's when it goes through. Correct, sir. I have this plane here, and I have a line, excuse me, and I have a line that is going through that plane. Okay? I gotta have another line here. Okay? Can these 2 lines intersect ever? Not really. Not really. Okay, one of them is going up and down, straight up and down. The other one is going horizontally. They're never going to touch. But does that mean that they're parallel? No. Are these guys in the same plane? No, absolutely not. So in order for a plane to be determined, you need 3 non-collinear points. A line and a point that is not collinear to that line, 2 intersecting lines, or 2 parallel lines. Does that make sense so far, guys? Yes, sir. Perpendicular lines can be on the same plane. No, they can be on the same plane, and they can also be on 2 different planes. It depends on what's going on here. You can have, in this particular case, these 2 lines are perpendicular, but they're on the plane. But, if I create a plane and I have this line here going through it, and then I have a line going through the plane, let's look at what happens here, okay? There is a perpendicular line here, but is that perpendicular? Are those created by 2 lines that were on the same plane in this instance? No. Again, guys, the best way to look at this, flat piece of paper, stick a pencil right through the center of it. Are those on the same plane? No. But are those perpendicular? Absolutely. But perpendicular does not define or determine a plane. Parallel lines, intersecting lines, 3 non-collinear points, or a line and a point that is not on that same line determine a plane. These are wonderful questions, and you guys need to ask these. So I'm proud of you. Anything else? Awesome, awesome questions. All right, let us continue then. Now, hopefully this will help bring some clarity If a line intersects a plane, this is what we've been talking about. This is the whole horizontal piece of paper with the pencil going through it. If a line intersects a plane, not containing it, then the intersection is exactly at 1 point. Again, my drawing is not as good as I would like, but that's the best that I can do. If a line, in this case line SP, intersects a plane, in this case plane M, okay? If a line, which is SP, intersects a plane M, not containing it, then the intersection is exactly 1 point. So SP intersects plane M at P. And where a line intersects a plane, that point, that's called the foot. That is called the foot. So a line can intersect a plane at 1 point and only 1 point. Yes, sir. Point P is the point of intersection of SP and plane M. So yes, is point P on plane M? Yes. Is SP on plane M? No. Now, if another line goes through P but is on plane M, then all the points on that line would be coplanar and collinear. Does that help?
Yeah.
Thank you, son. Yes, sir.
How about if the line AB defined it through as if you got it for the intersection with AB would go through it?
The question was, what if AB went through SP but not through P? For example, something like this.
That is technically not going through it.
Thank you. The answer is then it's technically not going through it. Again, get a piece of paper, put a pencil through it, draw a line on the paper. Are you going through the vertical line or the pencil? No. The answer is no, absolutely not. You may be going behind it, to the side of it, but you are not going to be intersecting with that vertical line unless your hand leaves the plane and goes up to touch the pencil. Does that make sense? Hello? Yes? Yes, sir.
He also
Yes, there is a plane in which SP belongs. P is also on that plane as well. Yes, sir. Now, if two planes intersect, their intersection is exactly one line. Now, in this one, my drawing is horrible, but the room that you live in, or the house you live in, or the room we're learning in right now. Look at this wall, please, guys. Right? The wall. Okay, woo, it's a wall. Look up to the ceiling, please.
that's the
Where do the wall and the ceiling connect, guys? At that corner, at that metal rail, correct? Well, if two planes intersect, their intersection is exactly one line. So I have plane M here and plane, let's say, Q over here. Plane M and plane Q intersect at the red line. There, you cannot see this as flat. You have to use your imagination, guys, and picture that plane Q is coming out towards you. Because it's not, they connect at a solid line. Are the ceiling and the roof and the wall, do they connect at a dotted line, or do they connect at a real line of real points?
no, but like what, like you know how like have a dot, so it goes like behind.
It's not a dotted line because it's not okay. If I wanted to continue Q, then I would dot behind it.
Yeah, that's
Okay? Because I didn't want a dot behind it because it looks weird and it makes things even more complicated. Okay? So that's why I didn't do that. Yes, sir. Okay. The only points that point M and Q can share together are on the red line. Those are the only points that they could share. Yes, sir.
Who's not on that plane? That
I'm sorry, I had no idea what you said.
like any point that's on plane Q is not M.
Any point that is on point Q is not on M except for where they are intersecting. Okay? Now, your homework is valid. You guys asked way too many questions here on way too many simple things. So, I'm not. Oh, wait, I have 5 more minutes. The bell's going to ring now? Okay. It is valid. We are valid.